want you to take that data set, and I want you to fold it in half. Don't fold the ends of the paper in half because I didn't cut these perfectly. Fold it so you can match the boxes up. Fold it so you can match the boxes up. Go ahead and take that piece of paper and fold it. This is what most of the lesson is going to be today. Now unfold it. What number did you just find?
Middle of 13.
In the middle of what?
13.
So what number is that? 14. What is 14? What is that called when we're talking about data? When we fold something in half and it's right in the middle, what's that called? You found the median. The median splits the data up in two groups, right? This group and that group. Let's look at the small side. What I want you to do is I want you to fold it in half again. So let's fold this, put that piece of paper back in half. Let's fold it in half again. Once again, matching the boxes up, not the ends of the paper. When we unfold it, it should look sort of like this. Right? It should look sort of like that. You've just split this data up into how many groups? 4 groups, and there are 3 dividing lines, right? The middle dividing line, we call that the what? The median. The other 2 dividing lines, they have a special name as well. Okay? And they have to do with what's called the IQR. The dividing lines have to do with, and we're going to glue these on, with this image here. If the median is in the middle, and then the lowest number and the highest number are right here and here, then what do you think these 2 are called? The 2 that the second folds you did. When you're looking at the image here, if the median is in the middle, and the greatest value and the least value are here, what do you think these 2 are called? Look at the image on your notes. What do you think we just found by doing that folding?
First and third quartile.
First quartile and third quartile. There are 5 points on these notes. The median is in the middle, the least and the greatest, then you have the first and third quartiles. What I want you to do is I want you to glue this in. I'll pass out the glue sticks. I want you to glue this in, and I want you to use this picture and what we just inferred with your data to find the information here. Now, this is new, but I think you might be able to figure it out based on the image here. This is new. I think you also might be able to find it based on the image. Okay, so I'm going to pass out the glue sticks. I want you to glue this in, and then I want you and the people around you to collaborate to get all of that information on the board. Okay? Even though it's not glued in, you can start finding the information. Okay? So start finding that information with the people around you. That can be your partner, it can be somebody else, it can be anybody around you. So all the people around you, get this thing glued in and start labeling. This is some sample data from period 2. It might be helpful to draw those lines, like where we folded. It might be helpful to kind of like draw like a bolded line where we folded. Here's that data again in case you missed it the first time. So with the people around you, you should be collaborating to try to figure out what those data points are using your data. Once again, it might be helpful to kind of bold where we made our folds so it's a little bit easier for you to see. There should be conversation happening right now with people around you, trying to figure out what these things are. Use the image on your notes to help you. So you probably turn it on. It's okay to be wrong. I want you to try. We're going to summarize this, but I want you to try it. Try to figure this stuff out. These are new words. So experiment. Try to figure some stuff out. for us.
And then median.
So we folded it in half to get our median.
I'm confused on.
The box plot is just a diagram. It's just a diagram.
Numbers is not the same.
Those numbers have nothing to do with anything. So this is just a picture. This is a picture of labels. It has nothing to do with our data. Okay.
So,
Yeah, just try to figure it out. Talk to your neighbors.
this would be further. So it's 17.
All right, that should have enough time to explore and to experiment. So I copied down your data. You guys should have it glued in, right? And it should look sort of like this. I asked you guys to maybe bold those lines where our folds were, so you'd be able to more clearly see them. When we folded, we split our data in half, creating what value? Our median, right? So this is our median. What was our median? 14. Okay? Our first quartile, so if you look at the picture that we have, the first quartile was where we did where we did the next fold, right? Remember how we folded it again? And I asked you, what do you think these are called? Well, Haley told us that they were called the first and third quartiles. Quartile. Why do we think they're called quartiles? What did we do? We folded it, and what did we get? 4 quarters. So we call these quartiles because they divide the group into 4 sets of data. So the first quartile divides the first half. The third quartile divides the upper half. So what was the first quartile? Yeah, 9 plus 12 over 2 equals 10.5, right? What was the third quartile? 17.5. Now this one was a little tough because it didn't tell you what it was, but I wanted you to experiment and see if you could kind of figure it out. The interquartile range. What did you guess that was? Olivia?
What the answer or what I did?
What the answer was? 5. Good guess. It's not right, but that was a good guess. Peyton?
I got 7.
Got 7? That's because that's what it is. When we think of interquartile, what does that kind of mean? Just the word.
Like in between the quartiles.
In between. Inter means in between, right? There's this thing called interstates. Did you guys know that these are called, there's things called interstates? They're the roads that go between the states, right? They're the roads that go between the states. So interquartile range is the range between the quartiles, and you can see that here. You see how it's labeled interquartile range? Where does it begin? At the first quartile. Where does it end? So the range for us, the interquartile range for us is right here, isn't it? That data. The interquartile range, ladies and gentlemen, is 50% of the data. How do I know that's 50% of the data? Because when we folded our data, right, it was split into 4 quarters. The interquartile range is the middle 2. What percent of the data is that? 50%. 2 quarters is 2 over 4, or 50%. So that's what this interquartile range is. We'll talk a little bit more about that in just a second. What's the least value? 2. The greatest value? 22. And the range? 20. These 2 values, interquartile range and range, are measurements of what? Do you guys remember what it's called? Measurements of spread. Measurements of spread. How spread out is the data? How compressed is the data? A median is a measurement of center. Everybody say measure of center. So what we're going to look at today is how the interquartile range is related to the median. Okay? Just like how last class we talked about how the MAD was related to the mean. Today, we'll use the interquartile range to measure spread when we talk about the median. Okay? Let's dive in a little bit more deeper about these. Let's take a look. So some vocab. When we're looking at these things today, we're going to look at a lot of box plots. Okay? Box plot is a graph that summarizes a data set along a number line. The number line is not the data. The number line is like a scale. Okay? A box plot is a graph that summarizes the data. it shows the median, it shows the interquartile range, and it shows the largest and smallest numbers. That's what a box plot does. It shows the median, the interquartile range, and the largest and smallest numbers. We use values called quartiles to make a box plot. The first quartile and the third quartile help set up the box. You guys see that image up there? The box is between the first and third quartiles. It's called the interquartile range. The box on the box plot is the IQR, the interquartile range. Everybody say IQR. The IQR is the interquartile range, okay? Divides the data into 4 equal parts. That's why half the data is inside the box, half the data is not inside the box, right? 4 parts. Half of it's inside the box, and half of it's not. I'm weird, what can I say? Adora knows it, she knows I'm weird. She laughs at me all the time on the inside. Chloe laughs at me on the outside. Last thing we got, the interquartile range. The interquartile range is a measurement of spread. Okay? The IQR gives us a numeric value that represents how spread out the data is. But why do we care about the IQR? Why can't we just focus on the actual range, right? You guys remember the age example that I gave you? What's your range for your ages? What was it was 1, right? The range for you guys, the range, 12-year-olds and 13-year-olds, what's the range? 1. You add my age in there, now the range is 19, right? But the IQR, the interquartile range, just looks at the middle 50%. So just take the middle age of you guys. What's the range? 1. Now add me in there. Just focus on the middle ages though. I'm in there though. What's the range? 1. Because the interquartile range gets rid of the top and bottom numbers and just focuses on the middle set. So it's a really good one because it gets rid of outliers. Okay? It's better than the range because it gets rid of those outliers. So like if I'm in your data set, it's not gonna completely mess up your range if you use the IQR. Okay? So the IQR is what we're gonna focus on today. Is figuring out what's the IQR, how can it relate, what does it mean for us? Okay? So let's look at this one problem and let's get the IQR. So we've got this data here in a graphical representation. I want to find the IQR, the interquartile range. Let's think back to what we did with our folding. To get the interquartile range, what did we do first? Folded it in half and found the what? Found the median. So what should we do with this data set first? We need to find the median. To find the median, we need to put it in order from least to greatest. So let's do that. So we've got 7 as our first number. What's our next number? What's our next number? Yeah, not 9, not then 10. It's not 7, 9, 10, 11, 12, 14. What is it? It's 7, 9, 9. How many 10s are there? 10, 10, 10. There's 1, 11. How many 12s? 12, 12, and then 14. How many data points are there? There's 10. So the middle number will be between 5 and 6. 1, 2, 3, 4, 5. Boom. What's our median? 10. Do we really care about that if we're looking for the IQR? No. We now have the median. We now need to find the first and third quartiles. The first quartile is the median of the bottom half. So let's look at the bottom half. What's the middle number on the bottom half? 9. That's the first quartile. What's the median of the upper half? 12. That's the third quartile. So what is my IQR? The IQR is a measurement of spread. It's the distance between those quartiles. It's the middle 50%. So what is that distance? 3. It's 12 minus 9, which equals 3. So now we need to describe the spread. Is this a large IQR or a small IQR? It's a pretty small IQR. So what can we say about this data?
That all the points are pretty close together.
Yeah, we can say that in general, the IQR is small. Therefore, the spread is small as well. The points are pretty close together. The data is fairly compressed. It's not spread out. Okay? What if this data then had 60 added to the end? What would happen? The median would shift from 10 to 10. This would shift to what? 10 or 9.5. This would shift to
12.
And the IQR would be 3 or 3.5 or 2. So I threw 60 in here. What did that do to the IQR? Nothing. Because that 60 is an outlier. And the IQR is a good measurement, it's a better measurement of spread because it isn't affected by those outliers. You see why the IQR is kind of a little bit more effective than the range? We threw 60 in here, it didn't really change the IQR. In fact, actually it decreased, which is kind of interesting. Okay? So just something to consider with the IQR. Okay? Let's analyze this box plot. This, during first period, we had a big time issue with this. Here's the deal. A box plot is a summary. There are no real data points on here. How many data points are on this box plot? Not 20. Not 30.
5.
Not 5. Not 4.
21.
Not 21.
9.
Not 9.
20.
Not 20.
23.
Not 23. Not 1.
3.
Not 3.
8.
Not 8. What'd you say? Not 21.
5.
Well, there are some. We just don't know. Are there 100 data points? Sure. Are there 6,000 data points? Sure. Could there be 5? Could there be only 4? No. There must be at least 5 data points. What are the 5 minimum data points that must be here? The least number, the greatest number, the median, first quartile, and third quartile. So there have to be a minimum of 5. Could there be 500?
Yes.
Yes. This is a graphical representation of the data. It is not the data. Okay? So there are some things we can figure out from this, and there are some things we can't. Okay, so let's try to figure out what we can. What's the median? 26. It's the middle number. But Mr. Strand, that doesn't look like the middle number. That's because this is a representation of the data. How much data is in each section here? Better question. What percent of the data is in each section? 25%, because what did the quartiles do? They split it up into what did it say by our definition?
5.
4 equal parts. The quartiles, think quart, right? Why does quartiles make sense to split up into 4 equal parts? Because there's 4 quarters in a dollar, there's 4 quarts in a gallon. Quart is that Greek or Latin? I don't remember. Some prefix. Quart means 4. Okay? So that means that 25% of the data is here, 25% of the data is here, 25% of the data is here, and 25% of the data is here. What percent is in the IQR? 50%. Half the data is in the IQR, right? This is half the data, and this is half the data. So the median is just the middle number, right? So this is the middle number. But it looks like it's not the middle number. That's just because this is more spread out. There must be a lot of 24s and 25s in our data set, right? There's probably just more 25s in here than there are these. They're just, it's not as centered, and that's fine. What's our first quartile? If you need to flip back to the front to help, that's fine. What is it? 24. Our third quartile? 33. All right, now what's our lowest number? 19, and our highest number? 39. We can use this data. Okay, let's do some follow-up questions. You guys have these numbers written down now? Great. Let's do the follow-up questions. These are some thinking questions. Okay, so we got to think. Which quartile has the most student scores? When you're looking at your data set, which one has the most student scores? We're looking at the box plot at the top of the back page. I'll tell you right now, this is a trick question. They what? They all the same amount. Because a quartile, what percent of the data is in it? 25% is in each quartile. 50% of the data is where? The interquartile range in the box. 50% of the data is in the box. What percent of the data is on each whisker? On each line? What percent of the data is on each line? 25%, because each quartile, 1, 2, 3, 4, contains the same amount. Do you guys remember when we folded the data? How many data points were in each fold? Flip back to the front. How many data points were in each fold? There were 5 in each, right? And I designed it that way. There were supposed to be the exact same amount in each, because the median and the quartiles split it into 4 groups. So let's find these statistics, if possible. So we're looking at that box plot that has no numbers on it, right? Can we find the mean? How do you find the mean? So add up all the numbers and then divide by how many there are. How many are there? How many numbers were on the box plot at the top of the group page?
Any number above four.
We have no idea how many there are. So why can't we find the mean? We have no idea what to divide by. We have no idea what to add up. We can't find the mean from a box plot. It's just not possible. We can find the median though, right? What's the median? 26. Can we find the mode?
No, because they're all the same.
We don't know. We have no idea what the numbers are. We can't find the mode if we don't know what the data is. Remember, a box plot is a summary, not the actual data. What's the range?
20.
What's the IQR, the interquartile range? Remember, the IQR is the quartiles, the distance between the quartiles. The interquartile range is on the box, right? What is it?
9.
It's 9, right? 33 minus 24 is 9. So we know that the IQR for this box was more than the thing we did in the front, right? It's slightly more than our data too, right? Which means it's more spread out than our data. Anytime you have an IQR, you can compare data points. You can compare different populations. And then there are no outliers on this because there isn't, like the whiskers, there isn't one whisker that's like super duper long, right? So with the box plot, you can get the median, range, and IQR. That's it. The box whisker plot, you can only find the median and the range only, but you can also find the IQR as well. So when we're looking at a box plot to compare data, what things can we compare? We can compare the median, the range, and the IQR, right? Those are the things we can compare because that's the information we have. Let's practice. So this is what we want to do. We want to write a small paragraph. Okay, this is the culmination of what we're doing. To compare the data, you should include information about the center. What's the center when we're dealing with box plots? The median. And the spread. What's the spread when we're working with box plots? Range or interquartile range. So if we're talking about soccer and football attendance, these are in hundreds. I want you to talk with the people around you. Compare these. Make some conclusions. Make some assessments based on what you see. Make sure you include comparisons dealing with the center and comparisons dealing with the spread. Give you about 3 minutes to get something written down and to talk to your neighbors about it. Okay? You should be comparing the measures of center as well as the measures of spread. What conclusions can you make about the soccer compared to the football? Keep in mind what measures of spread we use and what measures of center we use. Those are the words we should be using. So what about the measure of center and measure of spread? In a box plot, the measure of center is 25. So I'm going to write that here. So we should be talking about this. And then what measures of spread? Which is called average. Which is what we're doing. numbers in your explanation. You don't have to, but if you can throw some numbers in there, it makes your explanation also, makes your explanation a little bit more in depth. Okay, let's get some ideas. In general, we can say that the football has a higher attendance than the soccer, right? In general, because most of the data is higher than this. It also shows that the football attendance is pretty consistent. Why? Because the IQR is what? The IQR is a lot smaller for football than it is for soccer. But it shows that soccer had a really high peak. Right? It has a higher maximum. What game was that probably? Sectional championship, cross-county game, something like that. Maybe like kids get in free day or something like that. Soccer is also more sporadic. We would say the spread is larger, right? The attendance is much spreader, much more wide. Whereas the football is more consistent. These are the kind of conclusions we need to be able to make from our box whisker plots. Talk about the spread, talk about the center.